Okay, I wanted to give you a revised solution on problem number 4 for chapter 7 because my interpretation was slightly different than your teacher's, and I wanted to give you the same interpretation, Summer. So the problem was we had to find the value of n, the number of samples we had to take in order to get a margin of error of 0.04 and with a 95% confidence interval. Let's go through that solution. We have to compute that for using the value alpha, which we get from the confidence interval. And this alpha is in fact related to the alphas that we talk about in chapter 8. But alpha is going to tell us what regions on the probability curve we need to be considering. We take alpha to be 1 minus the confidence level divided by 100. And in this case, we're given a 95% confidence. So that's 1 minus 95 divided by 100, or 0.05. And what that means is that if we were going to look at our probability curve, what we want is that to have a 95% of our probability in that confidence interval. That means that 5% is outside the confidence interval. So 5% is outside, and if that's 5% is this area plus this area, it means that this area by itself must be 2.5%, which is the motivation behind computing this critical probability that they call P star, which is 1 minus alpha over 2. That's 1 minus 0.05 over 2, or that's equal to 0.97. Sorry, that doesn't look too much like a 7.5. So that's going to be the probability in this area right in here. Now, what we want to do is we want to find the z-score, that is the value here that corresponds to this probability being 2.5%. And we get that just by looking at the z-score curve or using a z-score calculator in the computer. And that's equal to a z-score equal to 1.96. So on a zero mean, unit variance, unit standard deviation, normal distribution, we pick the z-value right here, and that gives us 2.5% out here on that tail. And the standard error is, in fact, our sample standard deviation S. It's our sigma divided by square root of n, or in this case, because we have a binomial probability distribution, it becomes the square root of p times 1 minus p divided by n. So this is the standard error. This is the standard error for a sample collection with n samples in it. Now, the margin of error is going to be this critical z value right in here, which z equals 1.96, times the standard error. So we're moving back from the z distribution back to the distribution for x bar. So that tells us then that our margin of error is the critical value 1.96 times s over the square root of n, or in our case, it's square root of p times 1 minus p divided by n. That's what I show right here. So this is our margin of error, is this critical value times this standard error. So I plug in. They don't give us a value for p, so I choose p equal to 0.5, which makes this 0.5 times 0.5, or 0.25. So we want to compute the value of n that gives us 0.04 equal to 1.96 times the square root of 0.25 divided by n, which I now simplify down to this expression right down here. So n is then going to be equal to the square of this value, or this number right in here, 1.96 times 0.5 divided by 0.04, the whole thing squared, which comes out to be 600. So that is the value of n that gives us the margin of error of 0.04 with a 95% confidence interval. Okay, I hope that helps, Summer.